Sup? How's everyone doing? Welcome to another Cherno live stream game engine series episode. I don't know, we're in the hundreds. That's how long this has been going for. How is everyone doing today? Let's see if we can compile stuff. So, C#, right? Everyone's favorite thing. Oh, I didn't tweet this. That's just classic. Every time. I did it once before the stream started. I was very happy. I was very pleased with myself, but game engine series live now. Okay, cool. Right. Yeah, I decided to put some jazz on today because I feel really tired and exhausted because I've been making this video for like the last week, literally, and it's gonna be probably like, I think it's gonna be at least 2 hours long. Like, it's a long video for the channel. And I won't spoil it yet, but there's nothing to spoil. It's really not that interesting, but it's just very long, and it was a bit tiring to make, and even more tiring to edit. So, yeah, so that's what's going on. Thanks, Peter, for 14 months of subbing. It's good. It's what I expect from Studio Cherno team members. Tim?
Yeah.
Are you subscribed on Twitch?
No.
You're not even watching the stream, are you?
No.
You're listening to it in the background.
Wait. But if I'm on stream, I don't have to subscribe because I'm part of the stream, and no streamer ever subscribes to himself.
Are you sure?
I'm
sure there are some people.
Do you subscribe to
Nah,
yourself?
I don't sub to myself. I don't think I can.
Okay.
That's what I expect you to do.
Yeah, well, as long as I'm part of the stream, it's fine.
Alright,
right?
well, we'll just remember this when we're evaluating the employee performances. Yeah.
Subbed on Twitch. Cross.
I won't forget. Alright. Let's see here. I don't actually know exactly what we're gonna do today. Let's just have a chill stream. Alright, I'm making the executive decision. We're gonna have a chill stream because I just cannot be bothered, to be completely honest. We're just gonna have a chill stream, we're gonna relax. We're obviously gonna get some work done. Hey, thank you, Amazing Nathan, for the... It's almost like amazing, Nathan, for the sub. Appreciate the support. But yeah, like, let's just have a nice, like, chill stream where we hopefully... Actually, I had a chill idea anyway, right? So last time, if you guys don't remember, what was it that we looked at? Pink Cube, I think? So Pink Cube, I believe... Oh, but we didn't even serialize stuff, did we? Great. I think what we basically created was the ability to add a script component to type in the exact name of the class. So sandbox.player would be like the full kind of name. And then if we hit play, we could use the WASD keys to move one of these entities around. And that behavior was scripted inside the player script. Here it is. So that's it. We've kind of got C# scripting working in the sense that I can obviously, you know, hit play and it will manipulate, you know, my entity just like I've written over here, which is great. And this player on updates being printed, which is what we see over here. So it's all hooked up and it's all working. The biggest thing really that we need to do now, I mean, there's a lot of back-end stuff. There's like a lot of back-end stuff and there's a lot of like extra features we definitely want in the scripting engine. So like we don't want to have to specify like the exact name like this. We'd like to have a list of classes we can kind of choose from. There's also obviously like many features missing, such as the ability to add like public fields that we'd also want to set here. But ultimately those are all kind of nice to haves because once you have C# hooked up in this way and we have a way to call this and you have a way to call back into the engine, you can theoretically make a game. Right, like having a kind of... Oh, Tim just subscribed. I can't believe you did that, dude. That's like $9 Australian. That's like a bun me.
No, it was like 6.
Oh, really? Oh, it's on special or whatever. That's like a lunch. You could have bought me lunch. And instead you chose to give 50% of it to Twitch.
Wow.
See, that's a bad employee. Bad Tim.
Wake up your mind. Wake up your mind.
That's funny. It's alright, now you get to see no ads. Although you get to see this live, on a different level of live.
Yeah.
Like IRL
if
live.
you mute your mic, I can still hear you.
That's funny. Anyway, so Is this employee harassment? Nah, I define my own harassment laws in this studio.
I'm above the law.
Yeah.
I'm above the law.
Yeah, we have our own system of government and like laws here in Studio Cherno offices. Oh, Peter was about to gift you a sub apparently.
Wait, can you
But you were too quick.
give it to specific-
Yeah, you can gift it to specific people. That's funny. Alright, so what the you've got Prime Gaming? What even is Prime Gaming? Well look, you got this little tag next to your name. See?
Huh.
Prime Gaming. What does that mean? Peter doesn't have that.
Yeah, I don't know. I think it's because I hooked up like Amazon Prime to my Twitch.
Ah.
But
You could have given me a Prime sub then.
I guess so, yeah. Maybe
For
I
free.
could, yeah.
Anyone have Amazon Prime, by the way? Because, you know, if you guys do have Amazon Prime and you're like, Tim, this is just an elaborate ad. If you guys have Amazon Prime and you haven't subbed to anyone on Twitch, you can give a free sub. Oh, look, like Neochroma with the Prime sub. Thank you. Appreciate the support. So there you go. Well acted, Tim. It's working. We'll split the money. Oh, and Avalier, thank you for Prime. All right, guys, keep them going. Couple more subs, and that's lunch tomorrow sorted for Tim and I. In like what 2 months when we get the money from Twitch. All right. Anyway, let's get back to the Game Engine series because people watching on YouTube are going to be very upset unless I edit this out. Oh, and NX Super, thanks for the Prime sub. Thank you, guys. That's it. That's lunch sorted.
Yep.
I guess I'm buying lunch tomorrow, Tim.
It's a hype train. It's a hype train.
Yeah, the hype train. Thanks, guys, for the support. Appreciate it. Yeah, so we got this working. I thought we would have some fun today, you know, unlike we usually do. And we kind of had the idea of possibly adding Box2D to the actual like API that we had for C# last time. But that was just like, you know, we decided to keep it simple and just do a few things for, like in the beginning, like such as the input and just being able to set like the translation. So that's what we kind of exposed to C#. But I thought today it would be fun to take this thing that we have, I just hide those physics colliders, to take this kind of existing scene that we have and actually make it so that we can like kind of, you know, add forces to this Rigidbody. Because this is actually a Rigidbody 2D. And it would be nice if we, and it actually has a script hooked up to it. But obviously WASD doesn't do anything because it has a Rigidbody. So Box2D, the physics engine, is controlling its translation and rotation and all that kind of stuff. So it would be nice, obviously, to be able to just like still move it and manipulate it, but still have it work with the physics engine as you would kind of expect. That's obviously a very common use case for a game and for a scripting engine in a game. So why don't we go ahead and add that? And so basically, like, there's probably not going to be many, we might actually encounter some new concepts here. I think we probably will, and we'll definitely refactor some of this stuff to make it a little bit more solid, because at the moment it's not solid in the sense that, like, you know, I think our, like, internal calls are just chilling over here in main, and we've still got, like, all this native log, and, you know, we'll kind of clean up this code a little bit more, and we'll expose the Box2D API so that we can, hopefully, move that around. So let's start with that. So over here in Hazel Script Core, oh, and that reminds me, I think what we'll do next time, hopefully I don't forget this, I should probably write this down, but what we also really need to do is separate Hazel Script Core from, you know, the actual game that we're trying to make. So there should be like, you know, essentially like a project, like C# project that we load. So a C# project that is like for the game that we're working on, and eventually for the project that we haven't loaded in Hazel, because we don't really have a project system yet. But once we have that, we can just have a DLL there, and then we'll also have the kind of engine, you know, script core library, which is the whole API for Hazel in C#, which is what this will become. So that's actually really important. And we'll talk about how we can, you know, load multiple DLLs with Mono and have them like work together, which is going to be very important. But anyway, for now, though, we'll have some fun. So let's get rid of all this like garbage that we have with the native logging, because I don't think we really need that. Like, it might have been nice to refer to that, you know, for the sake of like just seeing how to expose certain things or how to deal with like different arguments and all that stuff. But I think like ultimately, you know, for now, if anything, we can look it up in Fork, obviously, and get and see what's up. But let's go ahead and start kind of creating this stuff. So in source, I think what I'll do is I'll add a little Hazel folder. So source Hazel is going to be all the stuff that's in Hazel. I mean, all of this stuff realistically will be in Hazel, but it's going to kind of match what we have inside Hazel, how we have source Hazel, obviously. And then everything kind of in here is the main Hazel API and the Hazel namespace, that kind of thing. So over here, I'll put in input and key code. Those are kind of our two Hazel classes anyway. And then I also want to, so player will keep out here. So the stuff out here will kind of be our game for now. And then main doesn't really need to exist. I think what I'll do, yeah, because main is interesting. Main is a file at the moment which has, basically, if I collapse this stuff, it's got a vector 3, it's got our internal calls, and it's got entity as well. Oh, Peter gifted a sub to eman40 lol, 40 lol. Thanks for the sub gift. Yeah, so it's got like entity, internal calls, and a vector 3 class. Like, what's going on there? Let's just rename this to like entity. It's going to become our little entity class, and we'll put it into Hazel as well. And then from here, what I want to do is I want to make a couple new files, a couple new C# files. One's going to be called internal calls. Internal calls. And one is going to be called vector 3. And this will just be all in Hazel. By the way, what I could do, and I should probably do this through pre-make. Well, I should definitely do this through pre-make, but you can actually set a default namespace. So we could just set it to like Hazel or something, and that will just, obviously that we'll lose that when we regenerate pre-make, when we regenerate our project with pre-make, but we need to probably set that there so that we can just, you know, automatically have it just be in Hazel namespace instead of like the folder structure. Okay, so public class vector 3. Now, it's not going to be a class, it's actually going to be a struct, and also we're going to go back to, I guess, entity and just steal it from here. And then we'll have our internal calls. Now, internal calls, we can make an internal class. So internal in C#, because it's kind of like a less known, I guess, visibility modifier, qualifier thing. It basically just means that this is kind of like public, but it's only public to this assembly. So it's only public to this particular project. So it's a good kind of, a good use of it is when you want, for example, this internal calls to be accessed by literally everything. So it's kind of like public for this entire script core. But like for our game DLL, we don't want that directly calling internal calls. So that's why, like, yeah, internal is good. It's almost like the default qualifier. I don't know. I actually don't know if there's a default visibility. I guess there is in C#. I know in Java, it just makes it kind of public to a package, to a particular package that you're in, which we don't really have in C#. So maybe it does a similar thing, but with namespaces or whatever. Default for methods is protected as Peter. Yeah, but I'm not sure what it is for this. Thanks, Anteen Tegier for the Prime sub. That's a fun name. So yeah, we'll make that internal calls class, which I don't know why I keep typing it out, because we'll just copy it from here. Let's just go ahead and include all of these things. Yeah, so that's what we're dealing with. We've got our kind of, all of our internal calls will be here, and we'll probably add regions and stuff like we do in Big Hazel as well, to kind of make sure that it's all as, oh, Ente ge in German, of course. Ente is duck in German. I know quite a bit of German, so I probably should have realized, but it was all like lowercase, so it was very difficult to read. But yeah. But isn't Go gayer like G-H-E? Or can you just say that for short or something? How can separate assemblies interact? Well, basically, separate assemblies already are interacting if you think about it, because we're loading stuff from system, and that's obviously not in this assembly, right? No, well, yeah, I get the gehe and there's go, but like, you can say ich gehe, right? Or is that's kind of the right. Not that my German grammar's amazing. Ich liebe Enten, I love ducks, that's me. But anyway, let's not get into a German lesson here. So, we had that stream once when I like taught stream the difference, I think, between some like Russian and Ukrainian pronunciation. That was a couple of years ago, that was fun. Ich gehe nach Australien. I'm going to Australia. So far, so good. But yeah, what I was saying with the assembly referencing was that, yeah, you basically just add references. And then of course you can, like we already are kind of using system and stuff that's not in this assembly. So it's very easy in C# to kind of do that. You know, it's kind of like an implementation detail that the runtime and like the virtual machine and stuff is supposed to handle for you. All right, so public struct vector3. Didn't I just copy and paste that? What? What happened to our vector3 class? Or struct? It's gone. That's a shame, we just like lost it. How did that even happen? What? Did you guys not see me? I'm gonna have to like watch the stream back, see what on earth happened, but we can recover it through fork. That's very weird though. I swear I pasted it into here. Oh, did I not commit last week? Oh, I didn't even commit last week. Oh no, we've actually lost it. Okay, so that never happened. We'll just undo. There it is. Huh, we didn't commit last week. Oh well, my bad. Okay. I should really do the committing on stream because that way I actually do it. Because, you know, as soon as the stream ends, that's it. I'm done. I'm done. See ya. Alright, cool. So that's all of our entity stuff for now, and we've got our internal calls nicely there, and we have that vector3 struct. So everything should still kind of work as it does before. Like if we look at player and we try and compile, well, like this whole binary, that should work. Good, brilliant. So let's talk about how we can expose some of the other stuff, right? So what we're gonna do is first of all, take a look at the C++ code that we'll need to run in order to make this happen, because that's going to determine obviously what the API looks like. But also, I guess we need a way to retrieve components, and I did want to talk about the component system and how that's going to work, because that is actually important, and that probably will be a little bit, I don't even know what a good version of Hazel is to open, Big Hazel to open. But that's gonna kind of, yeah, it's gonna be important for this. Thanks. We've got IRL bless yous instead of stream ones. But yeah, basically, we're gonna have to retrieve like basically some components and stuff by their type, hopefully. So the way this is gonna work is we're gonna have, I'll just probably make a folder called scene, which is where entity is going to go into, and all stuff related to entity as well, such as like the components. I like to keep the components all in one class as well, like they are in C++. And so what we're going to do is, okay, so it's not going to be called components. We're going to have all of our components here. So let's start by having like a transform component, right? And then what this is gonna be basically is there's gonna be a whole bunch that we should probably have a base class called component. I think that's what we do inside Hazel as well. Yeah, we basically just, the way that components work in C# is we're gonna have an abstract class called component that everything's gonna derive from. And basically this is just gonna have an entity, right? And we can just call it entity as well. So get, and in Hazel, we've got it set to internal set. So basically, and I mean, this is a bit weird, right? Like if you're familiar with an entity component system, usually components don't just own entities like that. But obviously this is just the C# interface for the ECS. So the idea is when we have a component, obviously it has a reference to an entity, it has to. And then that will determine when you actually kind of, this isn't like the storage of these components, but when you do decide that you want to access this transform component and do stuff to it, it will kind of communicate with C++, you know, by doing something to a specific entity. That's important. So that's kind of how that's set up. And then with transform component, again, like as an example, right? If we have, so we kind of just had, I think we added translation into here, but what we really should do is probably have this retrieve the transform component and then apply translation to it. I mean, this is kind of a shorthand for it, and we can still have translation inside entity because that's very useful, but we probably should set it up so it goes through the actual component, since that's where the data actually lies. But basically what I'll do is I'll expose a couple things here. So we want to have translation inside that. And, you know, we'll have get set. And get will just basically return internal calls. Oh, we probably won't do internal calls. We'll just do vector3 translation. Oh no, we can just do out. There'll be an out vector3, right? So this is going to be very similar to what we just did with get like we already have a get translation, right? So it's going to be very similar, but see, you see how we need an entity ID? So that's where we're going to use this entity that's going to be in that base class that we derive from. And then we'll do, you know, out vector3 translation, and then we'll like return translation. So that's kind of the way it's going to work, except instead of entity get translation, we're probably going to change this to be like transform component get translation, because we're going to make it kind of go through this transform component. So transform components, that's kind of like the way we dress this up. We just have internal calls as like the namespace, or like the static class in this case, and then we have like transform component as like the class name that we're in, and then the function on that, right? And that will kind of link back into C++ as well. So that's kind of what it means. Strunky, thank you for the prime sub. Appreciate the support. Okay, yeah, so that's kind of how it works. And then obviously with set, it's going to work very similarly to this. We just do set translation instead of get translation, and we should also change that to be transform component. So there you go. And Rustico Bacco, thank you for the prime sub. Appreciate the support.
Alright, yeah, I'm out.
See ya.
See ya.
See you tomorrow. Yeah, so we have that ref translation here instead. So we'll just do ref value, I guess, because we're setting it. Is that what we did inside entity? Yeah, we just did ref value. Cool. And I think that's probably it. So this one's a nice, easy one. And then the way that's going to work with entities, for example, when we do get translation, we're going to have to get that component, which is going to be the transform component, which we'll figure out in a minute, and then just return basically the translation from that. Now, as far as performance goes, this is obviously a little bit worse because get component's probably it's going to hit the native code. We do have a caching system now in Big Hazel as well, which we'll probably eventually add to this, but it's fun to do things the simple way first and then introduce optimization, because that way, you know, it gives me an opportunity to kind of teach optimization a bit more and also see the before and after, right? You need that kind of A/B test, otherwise you have no idea if what you presume is faster is actually faster. I don't really know about heap allocations to do with like this specifically. It should probably be okay. I don't know if that will be the problem. But basically, yeah, it's just going to be a bit annoying because we are going to have to go to native code like twice essentially for this kind of stuff. Whereas we could have just done it a single time and then obviously marshaled across the struct, which is, you know, just easy kind of layout. So that's going to be fine. Like, I don't think that it's a... I don't think, like, it's clearly going to be a big difference compared to, like, get, you know, component and all of that stuff. So I don't know. I don't buy that heap allocations would have reduced the speed too much, like, in these scenarios. Like, of course, like, they're not ideal, but I don't know if they'd be visible in the context of this. So I don't know. I think that may need more investigating. But basically, yeah, so get component, transform component, translation, and then we'll do the same thing. So this, like, the idea is if you are hitting this every frame, actually that reminds me, Peter, we need to talk about your caching code, because it doesn't, I don't know if Tim's already talked to you about that, but I had to fix a bunch of stuff there because it just did not work, and it caused some very funny issues, like seemingly impossible issues when we were working on the animation demo. But yeah, I don't know if he's pushed that or if or if he's mentioned that to you, but that was fun. So anyway, yeah, like what we should do ultimately is basically, you know, it would be a good idea to not like have to hit the native code to retrieve all the data we need for this every time we want to retrieve like an entity translation, since that's very likely a hot path, right? Like you might have 1,000 entities in your scene. They're all moving somewhere. They're all potentially setting translation. I mean, they might be setting transform or something else, right? But they might be setting translation. And if each of those entities needs to do twice as much work as it really needs to, that's potentially an issue. But we'll get to that. So how do we call code like this? And in fact, like, how does that work back in player? So if we did want to write this out the long way, instead of just grabbing translation like that and doing stuff like that, you know, we could, like, what we fundamentally want to do is we want to be able to retrieve any kind of component we want. Now, you know, you could also do this in onCreate, so that you're not calling get component too much. But again, calling get component might not be a problem. It depends on the implementation of get component. It depends on what it does. If it's just like retrieving something from a cache that's already in C# memory, like that probably isn't that big of a deal. It's like a map lookup potentially, or something like that, or an array lookup. It could be very, very fast, and that could be fine. If it's obviously hitting native code and then creating C# objects all the time on the heap, that might be like an issue. But anyway, so yeah, so one way we could go around that obviously is just calling it in like the constructor. So the idea might be, you know, let's write some sample code here. So we have like a transform component, which might be like our transform over here. And then we just want to set it equal to get component transform component. Now we want to use this as the type because get component is going to be a function that returns any possible component type. But this is what we kind of like programmatically, I guess, feel like writing. There's no real necessity to write that. It's just good because it's obviously using the type system that's built into the language. We could write a function called like get component transform component like that. And I mean, that wouldn't be the worst thing in the world, I guess, because if we just look at all the get components, it would give us a list of existing ones. So it's not like we're doing something weird, like providing it with a string, which we could also make work. But that would be very annoying because now we need to make sure that there aren't any like spelling mistakes here, or it's impossible to see potentially what the existing, like all the ones that do exist. We could even have get component, and then we could have something like transform component.id or something like that, right? So maybe transform component, each component maybe has some kind of like static int called id, and like, you know, for transform components it might be 1, and then that way what we do, something like that, right? I don't know exactly how this works, but we might have something like that. I don't know if that necessarily needs to be like that, but if we have something like that, then of course we could just pass in like an integer ID that could hit the native code, and that could give us back our right type. The reason why it's really good though to use the type system like that is because you can imagine that if it's kind of like, if we use generics for this, which is kind of like templates, but if we use generics for this, then the type here that we use is the return type, and that makes things a little bit easier to deal with. So that's ultimately why I think this approach is nice, because it means that, you know, we can have basically like a public T, you know, get component function. And first of all, T, right, is going to be like the type that we end up using as well when we decide that we want to have like some kind of type being returned, right? But ultimately, we can also add certain kind of concessions to this, which I think is good as well. So for example, like what we've got inside Hazel is, you know, obviously T has to be a component, right? You can't get around that. So if we have get component, non-generic, how do we make this? All right, yeah. So we have get component of T here. Yeah, good. Okay, so where T is a component and also a newable object, right? So it has to be an object that we can call new. I don't remember exactly why this had to be there, just in case it's an abstract class maybe, or something like that, or it needs a default constructor or something like that. But basically get component here can now actually go into like the native code and ask for a component of this type. Now the way that this actually works is that every type that we add here in C#, because how do we get this C# type to go into native code, into C++, and then work like, you know, how do we use that to then look something up? And I remember that was kind of an interesting experiment back when I dealt with it. But ultimately, and like the code has changed so much, there's going to be like a bit of a pain for me to even find like what's going on. But basically what we have is we need to have some kind of for each one of the components, we need to have them like declared as a type. Yeah, so if we look at Big Hazel, one of the critical steps here is register component types. And this will go through all the component types that we have inside the engine, and it will call register managed component. And so what that does is, well, let's take a look at what it does. So step one is we get the component type name, right? Using, I guess, type info, which this is a bit different than what I wrote, but this looks like some kind of struct, which we create with whatever this component is, along with, sure, exclude namespace, and we have type info base. So this is a bit, this almost looks a bit excessive to me. Type info base, demangle type, and then that will, based on if you have this set to true or not, it will try and set that up for you, sure. So that's all just to get the demangled name, but we use the type ID for that, right? So we pass in, so this is kind of like, yeah, this is kind of like type ID. If we had done something like type ID, you know, what's an example? Like transform component, and then we want to get like the name or something for it, but obviously we can process the name and like get, you know, some kind of properly formatted name, which is what this is trying to do. So we get that, we add the Hazel to it. So this is kind of interesting. This is kind of an interesting way of doing it. I think we did it slightly differently, but basically what we're trying to do here is, and where was that? In script engine? No, in script glue. What we're trying to do here is we're trying to take a component here that is in Hazel. This is the native component, right? We're trying to take that and we're trying to convert it into a string that is the C# fully qualified component name, right? So transform component from here actually becomes Hazel dot transform component, right? So now we have the component name, and you can see this is the important part. We do manage type mono reflection type from name, and that's the mono function we call to actually get, you know, we pass in this kind of string buffer here. Interesting that you're passing in the data pointer and not like the C string. I guess because it wants a char pointer, not a const char pointer. And it's not like a string view or anything. Because data, like semantically, data a lot of the times in C++ can mean that it doesn't include the null termination character. Obviously it does here because it's a string. But that's why I prefer to use C string. The only difference is that this is going to be a const char. And obviously this function needs a char pointer, which again is a bit abnormal. I don't know why it requires a char pointer and not a const char pointer. But that's a bit weird. Makes the code look a bit weird. So it's just Mono's API, I think, being weird. Peter says yes, because Mono isn't const correct in any way. That's brilliant. I don't know why. Cool. They just don't know what const means, I guess. So script engine get core assembly info, and then we get the assembly image, and that gives us the actual managed type. So if it can't find it, it can't find it. Otherwise, we have special component creation functions, has component functions, remove functions. Yeah, I remember setting this up back in the day. So basically what we do here is we have this like map, right? We have an unordered map of monotype pointer, which is we've determined will be the component type in C#. And then we have this kind of function pointer, essentially. We have a function that is going to be the component creation function for that component. So what that lets us actually do is instantiate the component if we decide that we want to create one. So if we look at, like, I think we have a function called, is it add component or create component? Yeah. So when the entity calls, like, if we want to create a component at runtime, so we want to add a component to our entity at runtime, should probably call it add component, not create component, but whatever. When we want to add a component to our entity at runtime, what it will actually do, and see here it actually uses mono reflection type, which is also interesting. We'll look at how that works in a minute. But basically what that does is it will call that create component function, right? So that we've actually set up ourselves. It'll call that to, you know, create the component by its kind of generic type, which is pretty cool. So that's how that works. And that's why we set up all these kind of lambdas here, which are those std functions. It's just a way for us to be like, hey, we want to, you know, we want to call like add component and all that stuff, which we'll obviously call the C++ version with this, but we're doing that obviously for the managed type. So we have a map now for all of these things, which is pretty cool. So this will definitely set up the same way. Yeah, also the other thing I wanted to look at before we dive into this, so like create component. So create component takes in a reflection type, which is very interesting, right? So create component is obviously something that we register here. So inside the internal calls, we're presumably going to have this create component, and you can see it takes in an actual type. And the type in this case is going to be like the C#, I guess, type. So if we go into entity CS and we go into create component, you can see that really component type is just type of T, and T is the generic argument. So that's how we can get the actual like runtime type of something, I guess, in C#, and then actually convert it into a mono reflection type that we can look at in C++. Which we then get the real type. So we do mono reflection type get type to get the type, and then we use that pointer as a lookup into the map to do our operations. So that's kind of like the full circle of how all of this works. Oh, I just realized I boiled a kettle before the stream because I was gonna make some tea and I forgot to. Rip. Can we get F's in chat for that tea? Oh, it's garbage. I hate that. Isn't that so sad when you boil a kettle and you like prepare like your little teacup with a tea bag in it, and then like it's just ready to go, and then you just forget about it. Kettle's going cold. Boiling water's just cold now, and you have to just pour the poor tea bag's just sitting there like in an empty cup. It's just the saddest thing ever. Anyway, I'm gonna go and make my tea. I have somewhat good news. It's still pretty hot. The kettle managed to keep it nice and hot. I mean, it's not boiling anymore. It's almost drinkable temperature, so it's okay. We're gonna be brewing our tea at like 60 degrees or something. Okay, that's 60 degrees Celsius, of course. So we're good. No need to cry too much. Okay, so yeah, so that's kind of our situation with all this, with this type system. So let's dive in and see what we can do. So get component's going to be, so yeah, with get component though, see, I guess I didn't cover all of that. That's just if you want to create a component, which sure is fine and all of that. But create, because this will obviously call all the right stuff and it'll be great. However, Chris Dev, thank you for the Prime sub. Appreciate the support. But however, the thing is, what if we actually want to retrieve a real kind of component? So we also obviously will have, okay, so we don't quite have a get component here. We have has component. Yeah, so get component is actually an interesting thing. Mind luck, thanks for the sub. Get component is an interesting thing because what is a component in C# really? Remember, C# is all about pulling puppet strings. So when we get a component, we're not actually retrieving any data about it, are we? We're just like, hey, you know, if we're trying to get a component, what we're getting is some kind of C# representation of that component, like almost like a handle for that component that we can then use to execute functions that will get us certain data. So for example, a transform component has a translation on it, right? So when we actually retrieve a transform component and put that transform component into our script, like we've done over here, we've got a transform component, there's no actual data in here. Yeah, this is just like the representation of an existing component. So really all it is at its core, the data it actually stores in C# is just the entity. which, what is that? Is just really the ID. And the idea is that when we actually do something with a transform, such as we want to set the translation, that's when it goes back into native code and says, hey, I have this vector3 translation that I want to set for the transform component on the entity ID that is stored within it. And that way it knows to retrieve, to kind of look up the transform component and then set that translation. Does that make sense? That's kind of what we're trying to do, really. So it's kind of cool if you think about it that way. It's not like we have to retrieve any data about the transform component to C#. That would be useless anyway, wouldn't it? Because at the end of the day, we need to set that data back into C++ so that it actually does stuff, because that's where the engine is. So that's kind of the, hopefully that now explains the full circle. So really all we're trying to do at the end of the day with this component, like when we're trying to do, so let's kind of make an example here. So we're going to try and set this to be kind of in the origin like that. Yeah. So again, this step should be really easy. And ultimately, I'm just going to use this like Big Hazel for reference, of course. Ultimately, all we're really trying to do with get component, and what we should do is we should check to see like if that component exists, because at the end of the day, we either return like essentially, you know, initially a brand new instance of the transform component with the correct entity ID set, so that we can then use it contextually for other stuff to actually set data, for example, or retrieve data, or we return null if it doesn't have that component. So the first thing really that we need to call is has component, because if it doesn't have the component, yeah, then we should return null. And that's what we're going to do. So has component has to be then another function which will return a boolean. It's also going to be generic and obviously have those same rules. And this is a bit easier to do because this will, at the end of the day, go into internal calls, right? Entity has component, we'll call it. And obviously this is no longer going to be generic because that's going to go into C++ code. We're going to actually find out the component type, and I'm just going to write it out explicitly so it just makes more sense. So type of T, and this type is what we're going to kind of push into here. Now, which entity? Obviously our kind of current entity. So we're going to include that ID here. So if it doesn't have the component, we return null. Otherwise, guess how simple this is? It's just gonna be return new T. Isn't that like amazing? And since T is a component, we know that the component has this entity thing. So what we can actually do is just set like entity equal to, well, basically this, because we're currently in entity, right? So we could just assign entity to this. We're storing an entity here. We could obviously just store an ID like as well, because that's kind of what's going on, right? Like we could say that, hey, we want to just maybe store that ulong, which is the entity ID, instead of an entire entity. That might be a little bit better, because but I don't think it will, because it's not like we're creating a new wrapper entity. We're actually just setting entity to this, right? And that's actually exactly what we do inside C#. Inside Big Hazel. So we just do like T component equals new T, and then we have like a caching mechanism, as I mentioned, so that we're not always creating new components every time we call get component and being a little bit wasteful with our resources and our heap allocations. But that's kind of the gist of it. With me so far, stream? So, next up then, yeah, so that's the implementation, right? So pretty cool. Like at the end of the day, what are we doing here? We're not even hitting C++. We hit C++ only for this because we do need to see if the component's there. Otherwise, this is a lie, basically. But at the end of the day, right, that's all we do. We actually just construct a new T, because that new component is going to be our like entry point, our puppeteer that's controlling the puppet strings that will call into C++ to actually manipulate the component in some way. So entity has component is the only thing that we really call here. So let's go ahead and implement that. So that's going to be inside internal calls, of course. I'm going to add it at the top, probably. I'll just duplicate like this initial existing code here. So it's going to be entity has component. We'll take in the entity ID. And then obviously we need type. is it just type? I think it is just type. So using system, component type. And yeah, like at the end of the day, right, has component, with that is just gonna call in to C++ with this type, which is going to be a mono, like reflection type, as we know. So let's do has component, and that's kind of it for now. We'll just do internal calls has component. We have component type, so what's the problem here? Void to bool, so yeah, this should return a boolean. And then if we go into our script glue file over here, let's go ahead and, so we have all of our functions here. Let's go ahead and add some internal calls. So we'll make one called has component. And then has component, let's just copy and paste this. Has component, I'll return a boolean, take in an entity ID, and here it's going to take in a mono reflection type. This is going to be our component type. And now what we can do is call mono reflection type get type, as we saw earlier, and that's going to take in our component type and give us an actual monotype back, which is going to be important. Right, this is like our mono component type. Now, why are you upset? It's undefined. Are you actually? No, you're just in reflection, metadata reflection. So reflection. Let's get rid of that. So that's our monotype now. However, we obviously still don't know if the component exists on this entity. So how do we get the entity? Well, we get the scene. We do kind of our default thing that we do everywhere else. We just copy and paste. We get our entity, and now we'd like to call entity.hasComponent, which is our C++ function. But we don't know what type the component is. That's the problem. So that's where that initial registration of component types was so important, because it gives us the ability to kind of translate between these two. Now, monotype, right, is just essentially this kind of pointer that we get for a particular type that is going to exist within the assembly. So, there's probably like a bunch of different ways to set this up realistically, but what we're going to do is, before we do any of this register functions, right, I want to make one more, which is going to be called register component types. Maybe we'll call it register components. And that's going to be the same as obviously what we had before, but let's kind of play around with this a little bit so that we can see behind all of the extra fluff that comes with Big Hazel, what's actually going on at its core. So we're going to get that managed kind of type first from a string. So this is where we can be kind of cool, because we can just say reflection type, get reflection type from name. And this is really cool because, again, we can just provide it with some sort of like string name. So for example, hazel.transform component, right? So this is now matching C#. And then what we need here is obviously a mono image. So this is where we ask the scripting engine. So let's see what hset add internal call does. So it does, it just adds as an internal call. So that actually has no context, which is fun, because that just works with the initial kind of mono system, I guess, and JIT and everything that's running. But if we go to script engine, we need to actually get some information about this. So mostly what we need actually is going to be this core assembly image. I don't know if we can retrieve that at all. Probably not. So we could add a friend class called script glue, and then we could add like some kind of function here. I mean, it's set up in a bit more of a deeper way, but for now, really, we could just say static mono image get core assembly image, right? So we'll just be kind of simple about it for now, and then once we go back and refine stuff, we'll know how to refine it because we'll be using everything properly. So that's a way for us to get the core assembly image, because that's what we need here. We need that mono image. So this will just be script engine get core assembly image. And that gives us our managed type, again, by name, right? So that's our transform component now by name, and we know what type it is. So now we just need a way to convert this monotype to an actual C++ type. So again, the easiest way to do that, and the way that we've chosen to do it in Hazel, is we can just pre-make the function that we want to execute. So we're gonna have, basically, at the end of the day, a function that just says, you know, we'll have to pass in like the entity, basically, but we pass in the entity, and then we just return entity.hasComponent based on whatever component we're currently dealing with, transform component like that, right? So we just make basically this little function that looks like this, and then we set this function, we hook that up to this monotype by using a map. So we can have a map, std, we'll make it static, so it's kind of internal to this class, unordered map, monotype, to some kind of std function of void, which takes in an entity as an argument. And let's see, another one of these, and we'll call it our hasComponentFuncs. Call it entity hasComponentFuncs. Now, again, having it static here, you probably want to maybe be a little bit more organized with it. But at the end of the day, that's what I'm doing. And I'm going to set, instead of setting it as like a local variable here, it's going to be set into the managed type like that. Right? So can you see where this is going now? If we now use this function inside here, instead of this hasComponent function, then all we need to do to use it is get that managed type, which I'll change this to be called managed type, right? So we can kind of just get it if it exists, which it hopefully will, and we can make sure it does as well. And then we call it with this entity. And that will give us obviously a Boolean result, right? Which I made it void, but it should be Boolean. Okay, so that's gonna give us that Boolean result, and that's what we can ultimately return over here. So that's how it works. Now we should be a little bit careful here. So we could do like a core assert to make sure that, for example, this actually, you know, has that. So we'll just say, does it have this managed type? Because if not, that's gonna obviously cause an error. And then we'll kind of, we'll basically call it with that entity. But you know, same thing here. Like we obviously want to assert over here. We want to assert a lot of these things, ultimately. We want to assert to make sure that scene here isn't null. We want to assert over here to make sure that entity also isn't null. And entity obviously will just have like a Boolean operator that we'll call. That's what's happening over here with this assert. And then obviously we're asserting here as well to make sure this exists. And that way, if we try and use a component that we just haven't registered because we've forgotten about it, then it'll help us out, okay? So that's how it works. So the only thing that's left here is, again, this. We have to call transform component, and then we call transform component here. So we have to do this for every single component type. Now, it'd be fantastic to use templates for this. Why? Because the way that we're set up with all of our components is we literally have an all components component group here that we can use to iterate through every existing component in our engine. So if we just use that system when we register components, there'll never be any unregistered components, which are going to be fantastic, right? So let's talk about how we can set that up. And again, that's the system that we kind of have inside Hazel over here. We basically just use this kind of type info.name to get like some information about this type. So at its core, what we do is we call type id.name, and then we demangle that name. So let's kind of take a look at how we can do that in a bit more of a simple way. Damn, this music's just accelerated. But anyway, yeah, so we'll do it in kind of a, hopefully a bit of a simpler way than Peter has done it in Hazel. Not that Peter's done it in Hazel a bad way. I just want to introduce you guys a little bit more softly to this. I don't know, sometimes I try and write code, like sometimes I try and write code like kind of naturally, and maybe I forget to explain certain things, or I write code in a too much of a complicated way. And then people leave comments such as like, I'm a beginner, I tried following this, and I didn't understand anything, you suck. And then, you know, Like, part of me is like, well, I'm writing a game engine and this is like episode 130 or whatever, so, you know, eventually we're going to have to get into some more advanced things. But also it makes me think, like, am I really doing stuff a bit too complicated? Like, should I save the complicated stuff for actual real Hazel, you know, when I'm just programming, you know, as a programmer, not as like a video tutorial creator, which I guess is what I'm doing now. Possibly. I don't know. Right? Like, because there's two factors to it. Like, if I can write it in a simple way and it makes sense and it works well enough, right, and it doesn't take too long, then that's ultimately good, I guess, in a way. But obviously, I'm never going to sacrifice, like, necessarily the quality of the engine and the performance of the engine just to try and do something really in a simple way, because that would make me a bad teacher, I guess, right? Okay, anyway, so what I would like to do is I would like to make a function called static void register component. I want it to be lol. I don't know why I wrote it that way. I want basically it to work like this, where all we should do is pass in just a template argument like this, right? Because that's going to make it compatible with that all components thing, right? We're going to have to expand all the template arguments from that group and then call register component on each of them. So if I'm doing this, right, how do I get information about this? Well, we obviously have this like type of kind of thing in C++, which is called type ID. And the real power here comes from the fact that I can access its name, which is going to give me a const char pointer, right? So I actually can access the name of the component here. So let's take a look at what we get. Let's do a hz core assert false, just to kind of break the debugger there. And then we'll just do like a core warn or something with that name here. So I don't know if I have to actually do that. I don't remember how this engine works. But if I do register component with transform component like that here, hopefully we should just see what the name of transform component is, and then we'll work from there. That's kind of my strategy for this. Okay, that didn't even assert. Okay, register components, I don't call that. So I think the script, is it the script engine that calls register functions? Yeah, so before we do that, we'll register components. Just makes more sense to me to register the type system first before the functions. All right, so here we go. So what do we have? So it's called Hazel : transform component. Now, all of them are really going to be called Hazel and then : transform component, right? However, like what I could do pretty easily is I could just say, hey, maybe this, oh, but it's also got the word struct in it, which makes it a little bit more complicated. So I think what I probably want to do at the end of the day, there's a few different ways I could go around this. I could basically split this maybe by space, which would get rid of the word struct. I could also like envision that it will always start with struct, and thus I might trim that out, right? But at the end of the day, if I do that, I'll get this, and then I could say, let's replace a double colon with a dot, and that would really give me like a C# compatible term. What I could also do is I could say, let's find last of this, and then let's grab the rest, and then let's append Hazel dot to it. And I think I might do that, just because that seems easier, right? So the way that would work is if I make this a string. So let's make this a string. And then we'll do find last of. And then we'll use the colon character. That's going to give us a string position, right? Which is going to be a size t. So position. It's always going to have that. Like, it's possible that it won't if someone makes a component that is not in a namespace, but that's weird. Like, I don't think that's something that it really is weird. And we can probably just like assert or something and be like, hey man, you have a component that's not even in the Hazel namespace, which isn't like valid, right? Because in that case, obviously, it would just say struct transform component, and then we'd have to get rid of this part. But I'm assuming it's going to be in this format, because that's just how the engine works. So once we have this position, we can obviously just do type name dot substring, right, with position, and then the count will just be that, which I assume will just be at the end of the string, obviously. So now we have, hopefully, our new substring, which is just the, I'll call it class name or struct name. So let's take a look at both of these things. So basically, I'll just say that becomes that. And I'll add little quotes around them so that we can make sure that we're not adding any spaces and stuff. That will just make it a little bit easier to read. So this is kind of like my strategy, right? I just go through, I run it all the time, I print it so I can see what the types are. Yeah, it's pretty good, right? Okay, so find last off, sorry, it finds the location of this, so we have to advance one more, right? Which, I don't know if it's better to add the plus before there or after there. Whatever makes more sense, but there you go. Then we have transform component. And now what we do is we say, let's get that managed name, right? Managed type name. And we say the managed type name is going to be, I'm going to use FMT format for this. We're going to do basically Hazel dot whatever that struct name is, right? And so that's going to give us our managed kind of type name. Yeah, I will use string view in a minute. I'm just demonstrating it the simple way. So struct transform component equals hazel.transform component, right? So that's going to be our final string that we end up with, and that's the string that obviously you can see now. Guess what? That is exactly what we use inside monoreflection type from name. So by calling this simple function, I've now produced a string that is in the right format, which is fantastic, right? Ooh, Japanese. Peter's made some Japanese curry. That's like what I did a couple weeks ago. Nice. Send a photo in the chat, Peter, like in Studio Cherno chat or whatever. Or you can send me, or you can DM me your curry. I'm gonna assess it, and it's gonna be part of your performance review. All right. So managed type name is now basically the correct thing, right? Now, as Rustico Bacco, I don't know. Anyway, as Rustico pointed out, we should use string views for parts of this. So what we've done here, I mean, okay, so there's a few things going on, right? First of all, type name over here, do we really need to make a string out of it? Well, not really, because type ID component.name gives us a const char pointer, which is basically like a compile time constant string, right? So making a string out of it will copy it into somewhere and possibly cause a heap allocation, right? If it's not using small string optimization. The second, the bigger, I wouldn't really fault people too much for this. I think that's decent. But this is where it's a bit annoying. When you do a substring like this, you're obviously just looking at part of a string. So when you're looking at part of a string, there's no reason to make an entirely new string out of it, especially if it's just a temporary thing that we're going to then copy here. Does that make sense? So let's kind of walk through what's actually happening here for those of you who aren't, for those of you who are string challenged. Why you use Rust and get out of here. All right, so let's go to like a bit of a smaller font. So our initial string, right? When we ask this for this, we get a string that says struct Hazel transform component. Regretting this font size. So what we want to do then is we want to be like, what we ultimately want to do is we want to just grab this portion of the string. But what we actually do is, first of all, we take this string and we copy it into another string. So we've got this at the moment. And then we copy it into another string that looks like this. And then what we do is we make a whole new string out of it, which is our managed string, which now looks like this. Whereas really what we could have done is we could have been like, hey, you see this area here that already exists? I want you to copy from here and place it here, thereby eliminating all of these, right? So that's kind of better. that will be better. So to do that, we can just use a string view. So you can assign a string view at any time, right? From like if you look at the string view class, it's actually worth, if you're kind of new to this stuff, it's actually worth reading about the string view API just to see how it even works. Because for example, like string views at the end of the day, like they're really just made up of like a char pointer and then also a size. And they're definitely not guaranteed to have any null termination characters or anything like that. University education. I don't have that stuff here. But anyway, they're not kind of, you know, they're not guaranteed to have a lot of things, but because they're really just like this const pointer to my data and then just the size of that, and that's it. Right? And then they have a whole bunch of API that you can use with them, such as find last off. So see, this part's very similar to what we have existing in the string. And if I just take a look at this, and you can see that even like C++23 and C++20 and stuff contains like starts with, ends with, some really useful stuff. So we probably will. .contains is pretty cool. That automatically checks that so that you don't have to do that for you. There's some nice stuff coming, which makes me want to switch to like, because we're currently C++17, right? In this project and in Big Hazel. Almost makes me want to just be like, yeah, let's just go to C++23 straight away. All right, so what am I looking for? I'm looking for substring, right? So it's also got substring, obviously, and that will just create a new string view of that offset. And you can see how easy it is. It just takes in the offset, it adds it to the data pointer. That is it. So at the end of the day, we can easily just replace basically all of this with just string views, right? The only part that I don't know if it supports that is format, but at the end of the day, we do want to create a real string out of it, because when we create this string, this is already, obviously we can't make this a string view. That's not gonna work, right? We actually can, the API will let us, but that's not gonna work because this is a temporary. We need to allocate some storage. You have to, a really good rule of thumb actually for people new to strings and new to C++ especially, I guess with strings, is you have to think of string as a container. It's a data structure. It's like a vector, right? An SCD vector or a list in C# and Java, right? That is really what it is. You know, you can see it's actually a basic string of char. I mean, if I want to be really cool, I could make a basic string of entity and actually like literally use it like a data structure. Like that is possible, right? That's how strings work. And so because of that, when you're creating a string, think about the fact that you're creating a data structure. You're allocating potentially, like again, small string optimization, all that stuff might be a stack allocation, but you know, at the end of the day, what you're doing is you're creating like this container of data. That's what you do when you make a string. So you always ask yourself, do I need storage for this? And obviously if you're creating a new string, yeah, you need some storage because you need to store it somewhere. But if you're just accessing parts of an existing string, no, you don't need it, right? So that's how it works. String builder is an interesting thing as well. So string builder is something that you don't really need in C++ because strings aren't exactly immutable the same way that they are in C# and Java. So in C# and Java, you really need to use a string builder. In C++, that doesn't need to exist because you can just get string to do everything you want it to do, which is great. Don't you also have to create a definition for char trace entity? Yeah, probably. I don't know. I haven't actually tried running this exact code. But I'm assuming that, yeah, because you'll probably need a type that's been defined for that potentially. I don't know. Don't try this at home, kids. It's just proving a point. Yeah, so anyway, so at the end of the day, this is kind of the slightly more optimized version of that code that we end up with. Let's just make sure that actually works. All right, and there you go. We have transform component has become, so we've gone from struct Hazel transform component to just Hazel.transform component. And you can see we've done it in a bit more of a simple way than we had in Big Hazel, which actually created like this templated class, which had a base class and like did all this stuff. And this is way more robust, don't get me wrong. Like you can see it's just doing some other things, but also because it's a templated class, it has that context. And it has operations supported around that context, which is kind of useful, right? I probably still wouldn't have templated the entire class though, like Peter did in this example, just because you know, at the end of the day, really all we need is the string. All of these other operations have nothing to do with T, right? So when you're thinking about whether or not stuff should be templated at the class level and doing all of that stuff, like, again, there are reasons obviously to do it potentially, but in this case, like, you could have just written a function that created a string and then passed it into like some type class which wasn't templated, because every time, obviously, if you have templated classes like that, it creates extra types inside the type system, and you can't, obviously, you lose that ability to have like a container of types or assign between types, because they're literally different types if they have different template arguments. Because when you create like a, you know, when you call a function with a template argument, or you create a class or a struct with a template argument, it's creating an extra variant kind of that type, which itself is a different type. But anyway, so yeah, that's that. So now, obviously, if I grab this code that we had here and I just kind of paste it here, now into manage type, we can pass in this. So again, mono, you can see, takes in char name for some ridiculous reason instead of const char, so we can't really do C-string. We can do C-string and we can cast it to a char, but that is something I would consider illegal. Like, and I go pretty far with the type system. I don't like const char to char is not something you should ever really do, just because const char traditionally represents immutable stuff and stuff that's in read-only memory. Not in this case, it clearly is not read-only memory, but still. We can do .data to kind of get the an actual char pointer, not a const char pointer, from string. We know it's going to be null terminated because it's a string. And then obviously manage type goes in here, and then has component instead of transform component, we just put in component, which is my template argument, which I chose not to call T. I called it component just because that is a bit more readable. And that's it. So we've registered the has component function for a particular template, for a particular component type, and we've done that just by specifying a template argument and not having to specify any kind of string or whatever. It just works that way, which is fantastic. By the way, we can obviously just make sure this works by putting a breakpoint here. Why is that a problem? Oh no, it's not. This is the problem. And why is it a problem? Cannot access private member. Oh, because this is not part of the script glue class. I don't really want to make it part of the script glue class. Let's just go to script engine, and we'll actually just make this public for now. Oh, but yeah, I mean, it's going to load an earlier version of the script core assembly probably, but let's see if it even has that managed type. No, it doesn't. It's null. That's funny. So hazel.transform component, not a type. Okay, cool. That reminds me, by the way, we need to make sure that we assert managed type, make sure it's not null. But the reason that's probably happening is because I don't think I built since I actually added transform component. So let's do a build here to see the error that we got, and let's fix that error. So this obviously doesn't exist anymore because it's going to be, now it's going to be transform component set translation. Oh yeah, that's the other thing I didn't point out. We don't really have to do this. I forgot about this entirely. Because at the end of the day, transform components are just these little fake constructs, right? And so what's actually happening is when we do get translation, we just need the entity ID. So that's really cool, actually. Out vector 3, result, return, results. We'll do that. That's something that I completely forgot to mention. So, well, I mean, I didn't really mention it, I just forgot about it in general. But basically, you can see the transform component doesn't need a transform component. It just needs the entity ID and the translation, right? The output translation. And same with this. It just needs to access a component, you just need the entity ID. So you don't actually need that component to ever exist. So what we can do inside entity translation is we don't need to call get component. We just do transform component get translation with that entity ID that we have here. And that's it, which is beautiful. Beautiful. Okay, cool. So moving on, does this build now? Yes, it does. Let's hit F5, run our engine and see if we get a managed type now. And we do. right? So mono reflection from type name has in fact worked. We can assert that, it's there, and we've created a has component function. So stuff is getting interesting now. What I would like to do now though is create one of these for every single component. Here's the deal though, guys. In order to do that, I'm gonna need to create every single component inside C#, which isn't a bad thing, but it's just some extra work that's gonna have to happen. Now, if we look at scene, just so that we can see, for example, in duplicate entity, an example of running through everything. So copy component, if exists, is a function that takes in all components and then expands it. So we're gonna have to create this kind of variadic template that will actually go ahead and do that, because otherwise it's not gonna work. So let's kind of use this for a reference over here. And then what we're going to do, so we're going to add a little ... This is going to be the variadic template version of this kind of register component. Oh, well, actually, no, I don't really think I want to do it this way. No, but we have to kind of pass it on, don't we? Which is a touch annoying. Because this is going to take in a component group and we'll expand it here, right? Yeah, that's doing the actual code here. Why is it doing it in a lambda though? So it's really it's just going to do that. Oh, because that's going to expand, I guess, every single one of these. Oh, I didn't know you could do it that way. That's kind of cool. That looks like a cleaner way to do it than what I had in mind. Cool. So let's try that. So there's actually going to be two versions of this. There's going to be, they're both going to be variadic here. But basically, this is going to do register component, and it's going to take in, what is it, all components, like that, I think. How was that taking it in? Oh, no, sorry. It takes in component group, like that. And it's not called, it's called component. No, it is called all components. So all components is a component group. So we take in a component group. But I don't know if it should. I guess it should, yeah. So we're taking a component group, component, like that. And then, so I'm just copying it from here, really. And then what we're gonna do is, for each of these components, basically, right, we're going to yeah, so we'll have to capture by reference here because we're gonna need, well, actually I don't think we have to capture at all because we're using static stuff. We'll add this all to here. We'll call the lambda and then we'll keep expanding it. And then over here, all we have to do is call register component with components, like just passing along that template argument, basically. And that maybe is it. So this goes here. And I believe we're done. Yep. Okay, cool. So that seemed to have worked. Here's what we're going to do. We're going to basically say if not manage type, we'll return here. Could not find component type. Managed type name. All right. Cool. So you can see it actually goes through all of them. It just didn't find all the ones that we didn't make, but you can see that it's not printing that it couldn't find transform component, because that obviously does exist. So I'm probably satisfied with this. In general, we probably should, you know, assert there as well. But for now, we'll just leave it as like, hey, it doesn't exist. Because I don't want to spend time implementing everything today. I was going to do, we're going to do box 2D. I guess we'll probably save box 2D for next time. Because this has just turned into like, how do we deal with component types between C++ and C#, which is good. And I don't want to like clutter the episodes, I think, too much with different things. And I'm tired and I want to go to sleep. That's the honest answer. What resource do you recommend for learning game engine architecture? Well, there's literally a book called Game Engine Architecture. This is what I recommend for game engine architecture. It's a pretty good book. And it's written by someone who actually knows what they're talking about, not like a career academic who has never actually written a game engine or worked in a professional team. So yes, it's a good book. All right, cool. So we've got all that stuff working, which is fantastic. We can just register all components, which is great, right? Let's what exactly? I think we're up to the correct. I think we're actually ready to test this. Because I think we're done. So now, obviously, get component doesn't work yet, but has component, well, actually, no, get component should work because it uses has component. So really, I mean, this isn't, even this might work. Damn. All right, let's not do that yet. Let's just try to do get component for now. So, right, what we're doing now is we've kind of rewired things a little bit so that we're going to try and set the translation through this get component instead of setting it directly like that, which we know works because we did that last time. Right, so let's not, that's not gonna work or anything, but let's see if we can actually get this component out of this. And one thing we'll do here is after doing this, I'm gonna remove this for now. I wanna basically test out whether or not we have the component. So we'll just print, let's do this. Let's print has transform. So we're gonna do has component, transform component, right? So we're gonna see if we can actually print that from the C# script. And if we go back to where were we? Script glue, right? Just want to make sure that we actually have that set up. Yeah, has component. I mean, yeah, it sounds like it. And has component functions, obviously, we've created that here as well. So that probably will work. Yeah, let's just run it. See what's up. So let's load, I think, that box 2D kind of thing, or the physics 2D, that already had that. Okay, so it completely crashed. All right, so the reason why, it's because set translation is weird. Yeah, so let's fix that up. So it crashed because those internal calls or whatever don't exist. So if we go to script glue, we've still got entity has component and get, we've still got get and set translation from the entity, but actually remember now, it's just called something else, but it does the exact same thing. All right, so we just need to make sure that we update that so that it matches what it is in C#. And then yeah, entity has component, should be fine, that should be fine, right? Why is it complaining? Has component undeclared identifier, really? Oh, I changed the transform. So this is entity has component, and this is set translation. I meant to change this bottom one. All right, so now. Zero. Wonderful. So it says it doesn't have a transform component. Strangely enough. Well, let's put a breakpoint here and see exactly what happened, because that is obviously wrong. Okay, so we're asking for the component. We have a seemingly valid entity ID. Manage type is valid as well. So, and we know that this doesn't occur. So then we just literally call, or we should be calling, let's go F11 into this. Yeah, we're calling entity has component. Which, oh, but which component are we asking for? Has T. Yeah, transform component. It's over here in the call stack. And that's returning false. What? Wait, hang on. Let's go to entity. Yeah, I mean, this is returning entity has component, which returns a boolean. What? That's a bit weird. Oh, it's the C# format people are saying. Oh. Yeah, I was a bit surprised, to be honest, because in my head, I was like, why is it printing 0? This is C++, it should print false. Because in C++ it would print 0. All right, awesome. There it is. True. Okay, so it does have that component. So now, let's try and actually grab the transform and try and set something like the translation. So we've got the transform now. So because that worked, we know get component will basically work, right? So now it just comes down to, let's try and use this actual transform component to try and set this translation. So we'll grab the translation from it and we'll set the translation on it. So we won't actually use the translation inside the entity class anymore. We'll just use that. All right, so let's see what that does. I mean, at the end of the day, it just calls transform get it just calls transform like get translation, set translation, all that stuff, which is correct. Like, we don't even need to really implement anything, which is amazing, right? So let's just make sure we build a script core, and then we'll hit F5. And now, if we actually, so we're trying to move our entity, right? So let's maybe, what should I do? I mean, let's just remove the rigid body for now from this, just because I'm not going to save the scene. But yeah, now you can see WASD actually moves this entity around. So it does work. Easy. And again, we're now doing that through the actual transform component. So before we go, let's have some fun with the rigid body component, and we'll explore this in much more detail next time. Now that we have our kind of component system, everything's great. So let's just grab our rigid body here. We'll make it a rigid body 2D component. I'll kind of match the type, obviously, that we have inside our components. Inside C++, so rigid body 2D component. So I should do a lowercase b. Rigid body 2D component. Yeah, I don't know why I capitalized B. I don't think I usually do I? Not sure. Anyway, let's close this. So I'm gonna make, obviously, this type. I'll just go to all the components. We'll grab this. We'll do rigid body 2D component. And now we have to think about what we actually want to do, right? So for this, I kind of recommend going into like, I guess, C++ and maybe starting there, because that way you'll see the API. So what we'll do is we'll go into you know, our script glue, and then I'm gonna make one of these guys. I'm gonna say rigid body 2D components, And then I don't know what it's called yet. I'll just leave it as set translation for now or whatever. I don't know. But basically what I'm trying to do here is obviously I'm going to do this same thing as always. And by the way, I should make sure I kind of keep these asserts everywhere. They'll be taken out obviously for release builds and for distribution builds. But for now we want to make sure it's working. So if I do entity get component, rigid, see, like we don't even need to know what it is, like in terms of the type system, because we know it's a Rigidbody 2D component function, right? So we just get the Rigidbody 2D component, Rigidbody 2D, and then what do we want to do to it? Well, we've got the runtime body, right? Which I think is, this is just a void pointer. Yeah. So obviously here we can actually do it. So what is it? Box 2D or whatever. Body. I remember the functions. If we go to scene though, we'll see. Oh, it's just B2 body. So we'll go up here and we'll include this. Now, I obviously like necessarily wouldn't recommend doing it this way exactly. Like I don't really want to actually use box2d here. I just want to probably call a function into the physics engine or something that will do that for me. Because that way I can also call those functions from C++ without having to like interact with this directly. But this will basically give me my body. And then I can do stuff. So I can like apply like force to it, for example, or a linear impulse. So let's try and do an impulse. Let's apply linear impulse. So we'll call this apply linear impulse. And we'll pass in a B2 vec2, all right, which is going to be GLM vec2 initially, which is going to be our impulse. And then we have point and then we have wake. So I'm just gonna copy that API obviously. So impulse, point, and bool wake. Now I could type on this, but I think I'm just gonna actually convert it properly. So yeah, I'll just do impulse X, impulse Y, and wake. Point X, obviously point Y, and then wake. So we've applied linear impulse, it returns void. That's it, right? Pretty easy. That's how we write a function like that inside our kind of script glue. Rigidbody 2D component, apply linear impulse. And now we can actually go into, obviously, components. We can do public void apply linear impulse. This is obviously the C# kind of version, right? So we just take in stuff normally. So vector2 impulse, that's just what box2d calls it. We could call it something else. Vector2, which doesn't exist, by the way, we're gonna have to make vector2 in a minute. Vector2 point and bool wake, which we could, you know, set to true or something by default if we wanted to, but we'll keep it like this for now. Okay, so let's go into, so we have a vector3 class, right? Can I copy and paste that and just call this a vector2? That would be nice. We'll call it vector2, 2, get rid of that, 2, 2, obviously just an xy, vector2, and we'll keep these existing operators as well. Because yeah, there's no point getting rid of them. All right, there you go. So there's our vector2 speedrun. Everything seems to be working good. I guess I'll go in here and also remove the stuff we don't need. So back in components, we now have apply linear impulse, which obviously is going to call the internal calls version, which doesn't exist yet. So we'll grab this. This is getting already a bit messy. Like you can see, there's a lot of different component types that are kind of in here, which is a bit annoying. Which is why it's good to kind of separate them and stuff. But we'll do apply linear impulse. We'll grab this stuff along with the entity ID, obviously, because we need that. So that's kind of the difference, right? This stuff takes in all of these things. This will take them as refs. However, it also needs an entity ID, which is what we're going to provide it with. So when we call the internal calls here, which is going to be Rigidbody 2D apply linear impulse, we're going to provide it with the entity ID, and then the impulse, the point, and the wake, and then these things will obviously be provided as refs, right? But then C# wise, we just call that, which is pretty cool. All right. Somehow we've lost a curly bracket at the end. Do we need struct layout sequential? I don't know. I don't think so. I think that's the default. So no, we don't need that. Well, anyway, it seems to be working so far without vec3s. So I'm assuming it's fine. Okay, cool. So yeah, there you go. That's that. Pretty cool. So now, again, it should be as simple as just going into like player. Let's just say that we wanna, if we press like the space bar or something, let's just say, I mean, I guess we could make it move in all these different directions, actually. Yeah, let's do that. I said I wouldn't, at the beginning of the stream, I was like, I'll do it today. Then I was like, we're doing all this type stuff. But you know what? Let's do it. Let's do it for reals. So with this velocity, I guess, at the end of the day, because it's going to be easy to do anyway, I'm going to get that rigid body, and I'm just going to do rigid body, apply linear impulse, velocity is going to be our linear impulse, point. Now, point, I believe, is relative to the object. So I think we can just do vector2 dot 0, and that's going to basically be in the center or something like that. And wake will set to true, which probably should set it to be that by default. Now, velocity is a vector3 for some reason, because we were using it for the translation. So let's just do velocity.xy, and we'll write a function to do that for us. So if we go into vector3, we'll write a little function here called public vector2. Well, actually, it'll be a property called xy. And that will, well, I guess I'll make it a get and set. So we'll make the get be just, let's just return new vector2 xy. And these are all kind of on the stack, so it's nice. And set is going to set, I guess we need to use a thing for that. X equals value x. And y equals value y. So now, yeah, we can just do apply linear impulse velocity xy, because that's what we want. And that's that. So we don't really have to comment this out because it's not going to do anything anyway. But let's build that. Let's hit F5. And I think we're going to work well now. So physics 2D. I actually don't know what's going to happen. Yeah, that worked. Okay, so that's way too fast. And also it's applying it every frame, which is a bit of a problem. So let's set speed to something like 0.1 maybe. I keep forgetting to build this. And this is actually going to be a great use case for having, obviously, a parameter exposed inside here. So if we can obviously just click on this and then be like, I want to set the speed here, that's going to be fantastic. So we'll eventually do that as well, of course. Okay, so that kind of works as well. Why is it actually bouncing so much though? That was a bit weird. It kind of came down and bounced a lot. Let's make it even slower. We probably should have just added force or something. Impulse is probably a bit too heavy to add every frame like that. But yeah, there you go. So W, oh, and it's spinning it actually. So it's not adding it from the center. Because see, if I press W, it spins it. But it does make it, I guess, go the right way. Right, and then for some reason it just goes up. But we can just take the camera and drag it out so we can see where it is. Oh, I'm pressing W. Nah, it's gone. Gone forever. Let's try that again. Let's move the camera out a bit. Yeah, see, I can kind of make it go up. It's just weird to me that when it crashes down on the ground, it just goes ballistic. Maybe because it was spinning so fast or something. Look at that, though. Yeah, see, look at that. We could also do fixed rotation, right? So now it's not going to spin. So now I can kind of move it with WASD keys, right? You can see how that's working. Awesome. So yeah, there you go, right? And by the way, another really cool thing you can easily do to this, right, which is why scripts are so cool, is we could be like, let's duplicate the player script. Let's call it camera, and you're gonna see how quick this is gonna be. Let's call it camera. Let's get rid of like all of this stuff because we don't need like any of it. Like we don't even need the onCreate function, to be honest. Let's get rid of that. And then all I'm going to do is I'm going to still do this same thing, but I'm going to set it back to 1, and I'm going to apply it here. So now, guess what we can do? We can just manipulate the camera's transform just like that. In like 5 seconds, I've done that, right? If we go back to our scenes, we load this, we load up the camera now. So we've still got our functionality obviously on this thing, right? I'll fix the rotation for now. Yeah, so we can move this. We just go to our camera, we add a script component, and then we say it's going to be called sandbox.camera. Yeah, and now we crash. Yeah, so perfect, guys, perfect. I'm realizing now that I actually didn't guard on create from being called, right? Which sucks. That's my bad. I should have done that because that ruined my whole thing. But basically, it's because I removed the onCreate function, and this really wants an onCreate function to exist, which is a bit unfortunate. So we have this kind of invoke onCreate, which obviously will, so initially we retrieve this kind of, we do get method onCreate. That's going to probably return null. Wait, where is it? Let's go back to here. We call get method onCreate. So yeah, that will return null. So obviously, I guess what we want to do is if that's not there, we won't invoke it. So we'll just do that. And we'll do the same thing with onUpdate, because we might not have an onUpdate. So that's what we'll do. Genuinely confused as to how you're not having anxiety over design decisions all the time. You're just implementing it at full speed is foreign concept to me. It's because I've already done it. The first time I went through this kind of mono C# integration thing, about 2 years ago, I think. Yeah, it took me longer, of course. Now I know what I'm doing. So, yeah. Okay, now you can see WASD moves both, the camera and the thing. I might want to move it independently though, so maybe I'll change this to be like the up arrow. This will be the down arrow. This will be left, and this will be right. Build that for the camera script. Hit play. Oops. Now I can move this with WASD, and I can move the camera with the arrow keys, like that. A little bit slow, I'd probably make it a bit faster, but there you go. And I could obviously easily implement the mouse if I expose that to C# and implement it however I like here, but ultimately you can see we have our Rigidbody 2D being used here, and everything is great. So there you go. Easy. Let's do something fun. Let's duplicate this. Let's call this, is it just called sprite? I think so. Let's call this like block. Let's change the color to something else. Ooh, we could randomly set the color as well. Oh, guys, we're gonna have so much fun with this. There's gonna be so much cool stuff we can do. But basically, if I do that, and I wanted to get rid of the script. Right, so I think now we just have this kind of block that we can ultimately interact with, which is pretty cool. Yeah, I've got the rotation fixed on this. Now, yeah, so 0, 0 apparently was, I thought 0, 0 would be the center, but it doesn't really doesn't look like it is, which is a bit weird. Because remember, we're applying that impulse to the center. So I actually want to kind of look at apply linear impulse box 2D. I want to look at this function on Google. Well, I want to Google this function. Oh, my eyes. So where's this linear impulse? Where's the API reference? This is like a tutorial. I didn't really want this. Here we go. Tutorials are for suckers, am I right? All the people watching the series. Oh, look, there was a to center function. To the center of mass. Okay, so this isn't taking a point. But look, this is, oh, the world position. Oh, bro, I knew something was wrong. Yeah, that's weird. I hate that it does that. Why would you not want it to go to the center of the body? I mean, it might not know what shape is attached to it and stuff. But this applies it to the center of mass. So this is probably what we want. So see, this is where I would definitely go through, right? And be like, hey, let's not call this point. Let's call this like world position. or something, you know, something just to make it clear that this is actually in world space, because otherwise that's crazy. And again, like obviously this is Hazel API, I could do whatever I want, I could apply an offset here. Maybe someone wants to do it from the world position though. So let's just make a little apply linear impulse. Let's just do an apply, we're not gonna call it to center, we're just gonna call it the same thing, but we're not gonna have world position. And so what that's gonna do is apply linear impulse basically to center, right? So we're gonna kind of cheat here with the API. We're gonna make it actually do something different here, where it's gonna call a function where it doesn't actually apply it to a particular point. It's gonna apply it to the center, but here it's gonna look like it's the same function, because I think that'll be much more, it'll be much better. So let's get rid of this here. Apply linear impulse to center is the name of that function. So let's go to our script engine. Let's, script glue. Let's call apply linear impulse to center. Let's duplicate our apply linear impulse. Obviously call it to center, get rid of point. Change this function to say to center now, and then we'll just get rid of the point. So we'll just take that in and wake, and we're done. Easy. Not a problem. So easy to just wrap stuff up and, you know, create new functions to call. So now if we go back to player, let's do apply a linear impulse, but instead of doing 0, we just won't provide a value. So that will now call, obviously, the to center function. So if we go back here, let's see how that works. Okay, that looks better, I think. Let's just let's just uncheck the fixed rotation. So now we can rotate it. And yeah, that looks great. So you can see it really only rotates when we do that. So now it does it like to center of mass, which is cool. This offset's kind of annoying me, by the way. So I think I might, let's just do something like that. And let's just set this offset back to 0. Because that was just testing whether or not offsets worked, but they work, so whatever. There you go. Look at that. I could already see a game where one of you controls this with like WASD, other player controls this with like the arrow keys, which currently moves the camera. And you can have like this little fighting game where you just fight. Yeah? Done. Done and C# scripted. Easy. Easy. All right? So that is how that works. That is how the cookie crumbles. Does anyone have any questions before I go to sleep? Oh, someone's quick with a question. How do I add a submodule to Walnut template? You just add a submodule. Git submodule add. Done. Next question. But yeah. Okay. So, in terms of stuff related to this though, that's pretty much, yeah, that's pretty much it. Yeah, obviously we're gonna have to expose a lot more stuff eventually, and there's just a lot more work to do in general, but hopefully this was kind of like a nice, good start, as far as like, you know, the beginnings of actually creating something cool using scripting go. Because obviously we could have done all this through C++, but the fact that it's done through C# is really cool, and it's going to become even more powerful when we realize that we can just reload these assemblies so that we don't have to keep, which reloading assemblies is a topic to explore as well, because there are some nuances there. But it's going to be even cooler, obviously, when we realize that we don't have to close the editor. We can just go back here, recompile it, and it will just work. Right? So, yeah. Do you still add scripts in Big Hazel by typing in the script name? No. So Big Hazel works a bit differently. I don't even know what I've got open here in Big Hazel. Hopefully it's nothing top secret. I'll try and launch it. We'll see if it works. No, I don't think it is. I remember what it is because I was doing some stuff today. We're gonna basically integrate the same system here. So instead of like at the moment, as you can see in Little Hazel, in Hazel 2D, it doesn't even have an icon. That's cute and sad. You can see we just have to type in like the name here, and if we get it wrong, then it'll be red. So at least it's got that going for us. But otherwise, we have to actually type in the name. So we've got player here. The camera has like you know, sandbox.camera. All of that stuff's there. In here, right? Oh, this was some fun stuff I was working on, by the way. I'll show you guys. Oh, that's gonna be bad. I was working on some grass, as I do. This is some top secret show and tell. Let's do 1 and I think 1.4 with some nice settings. Then we'll make this green or dark green or something, and there you go, we've got some nice grass. This is like a very heavy grass thing. It's like, I think this is like 35 million triangles or something. Oh, is it lagging on stream? I think it is. It's not actually lagging for me. That sucks, I can't even stream this stuff. Weird. Yeah, I can't tell if it's right. It's lagging inside my Streamlabs OBS. Maybe I need to use game capture or something. But no, it's running at 10 milliseconds per frame. Yeah, it is lagging. Okay, let me see if I can do a game capture. I think I have some kind of game capture. Yeah, I thought it was lagging. Let me see what I can do. Yeah, but the thing is, this can never, oh, maybe, here we go. Wait, will this work? Nah, it's still lagging. I don't know how I can capture it properly. Like, I can do it in OBS, but Streamlabs OBS, I'm not sure how. Capture game. Because capture game just says looking for game to capture. It's like, thanks, bro. And then the screen capture doesn't work. Huh. Yeah, because look, even I'm lagging. Alright, well, rip. I can't show you guys any beautiful graphics, sorry. Because the next thing I was gonna show you was that with, like, you know, some depth of field and stuff. But I guess there's no point really showing that either, because it'll look laggy on stream for some reason, which kind of sucks. Yeah, that sucks. Stupid Streamlabs OBS. But anyway, let's remove the grass for a second. Is that performing better now for you guys? I don't know. Yeah, okay, it is. I don't know why. I think maybe because it uses so much of the GPU that there's just not enough for encoding for Streamlabs. Maybe that's why. I don't know why. Yeah, I know. I think I'm gonna stop using Streamlabs OBS. I really don't like it anymore. I'll just go back to OG OBS. I record my videos with OG OBS usually. Anyway, yeah, with what I was gonna do here was say that the reason we opened this is actually not even the right project, by the way. Let's go back to Sandbox. Okay, so if we look at Sandbox, so you can see this actually is like something we can kind of run and play with. Oh, did not load the script stuff properly. Well, great example then. Okay, I might have to open a different branch of Hazel. But I've got secret stuff in other branches. Alright. Hold your horses, everyone. No, this one's not secret. Will you try a dual computer setup? Nah, I don't think I'm that keen. Okay, good. So this is the working version, right? So, like, we have a script obviously running on the player, and you can see that this is the script class over here, right? And if we click on it, yeah, it's not like a string we type. It's just, it lists all of the possible classes that we have in the compiled binary, and obviously we can search for something. So we can be like, you know, I want this cube to have a script, so we add a script component to it, and then we basically are like, I don't know, I want it to be like the player or something, and here's like something that matches player, done, right? And then it gets all of the different fields and all of that stuff here, right? So that is how we will make it work, you know, inside here as well, eventually. So yeah, let's see. Yeah, so instead of that string, so that will happen. But other than that, that's what we've done today. Oh yes, I need to commit. Thanks for reminding me, myself. Okay, so here's all our stuff. So apparently we did this, so we can just revert that. Oh, no, hang on. Is that all we did? Yeah, it is. Okay, let's revert that. So this was, we did a bit of this stuff last time as well. So we added obviously script component last time. We added a bunch of stuff to scene. Get entity by UUID, that was an important function we added. And the entity map as well is important. Script component, serialization and deserialization, very important. To the script engine, we added just a bunch of stuff as we were working through it. We could load stuff and we managed to call functions and call back into C++. All that stuff we did last time, so you guys can just watch the latest or the last episode on YouTube. Script instance, script engine, all of that stuff. Script glue, we obviously added a bunch of stuff to today as well, like this whole register component situation that we can now do, which is nice. This is us playing with the physics 2D scene. And the scene hierarchy panel, we also obviously added this kind of functionality so that we could actually type in a script name. And yeah, this is all the other kind of script stuff that we did today. Sweet. I don't know why that happened. What do you mean you can't add entity? That was a bit weird. Now it works. Cool. Let's close this actually. I mean, I'm sure it's not going to write files or whatever. Okay, script glue. We've got everything saved here, right? Yeah, I think so. All right, cool. So there you go. That's all the stuff that we've done. So, we did a lot of stuff, didn't we? Like, I don't even know what to say. Lots of like scripting work. I'll say added script components, added components, added component functionality. I'll say to C#. Added Rigidbody 2D C#. I don't know, script demo, I'll say, to physics scene. Is that what it's called? No, it's called something else, isn't it? Could have just looked here. Yeah, physics 2D. To physics 2D scene. That's probably good enough. Oh, added, I'll mention that I added entity map to scene class, because that's important. All right, cool. And then, so that's going to go into the scripting branch, of course. So that's now pushed, so you guys can pull that. Just make sure that you build this, because I'm not going to commit the binary. So make sure when you run premake and generate this, you actually compile Hazel script core, otherwise it'll probably crash or tell you that it doesn't work. And then if you run, obviously, Hazel yourselves, and if you open up Physics 2D, you should be able to play this little situation that I've created here and use the arrow keys to move the camera, and hopefully that will all work for you guys as well. All right, so that is it. Hope you guys enjoyed this video, this episode of the Game Engine series. Next time, we are going to continue on with all of this stuff, right? We're gonna probably add, well, we have to add all the different component types. I would like to create a cooler demo. So for example, we could add like the sprite render component and have it like randomize colors and stuff on create, right? So that when we spawn in, we get all these colors, and maybe we can make a little game out of like all these colorful cubes falling down, and then you have to like escape from under the rubble or something. We can hopefully also create entities on the fly using scripts as well. So use scripts to actually instantiate entities. That would be cool. Although that will, like, doing that properly involves adding prefabs, which is a system itself. Like, there's, yeah, lots of stuff that we have to do. So yeah, but anyway, I hope you guys enjoyed this video. If you did, don't forget to hit the like button if you're watching on YouTube, patreon.com/thecherno. Best place to support, obviously, this series and everything that we do here with Hazel, and you'll get access to Big Hazel. So what I showed earlier, you'll be able to play around with that and make games with that and do all of that stuff. And yeah, I'll see you guys next time. Goodbye.